As we conclude the Examining Distributions series, let's take a few moments to review what we have learned. I'm not going to teach any concepts in this video. Rather, I want to quickly list those concepts that I have covered in this series. If any of these terms seem unfamiliar, I invite you to review the previous videos in which I discuss that concept. We learned a few graphs and statistics that we can use to examine the distribution of categorical variables. Data that are categorical variables vary by category rather than quantity. To show the relative frequency of units in each category, we can use bar charts. We learned about pie charts as well, but that is only because pie charts are still used by some researchers. Statisticians caution against using these charts. I hope that you choose bar charts when you want to show a graph of a categorical variable. Sample size is the number of units in our sample, regardless of whether the variable is categorical or quantitative. We can count the frequency in each category of a categorical variable. Better yet, we can calculate the proportion or percentage in each category, thus allowing for more direct comparisons among different categorical variables. When displaying the distribution of a quantitative variable, a histogram illustrates the shape of the distribution. One of the most useful graphs for quantitative variables is a box plot. A box plot illustrates the position of special percentiles along the distribution. This allows us to better understand both the central tendency and variability of a variable within a single graph. A time plot is a special graph when we are interested in looking at variable change over time. Global and local modes help us know what scores are most common in the distribution. The global mode looks at the most common score in the entire distribution, but is less informative than the local modes that are common scores across the range of the distribution. The median and mean are the two statistics we learn for identifying the center or central tendency of the distribution. We need to accompany an understanding of center with an understanding of the spread or variability of the scores. We can look at this through the range, the interquartile range, and the standard deviation. Understanding how a score fits in the distribution helps us make more meaning out of that score. To assist with this, we can calculate relative position statistics. These include the deviation score, which is in the original units of measurement, and the z-score, which is in standard deviation units. We can also calculate the percentile rank, which tells us the percentage of units in the distribution that are below a score. Quantile is a general term for position on a distribution. We focused on special quantiles, such as the percentile, which looks at the distribution broken up into 100 parts, and the quartile, which looks at the distribution broken up into 4 parts. We can list some special quantiles in a 5-number summary. Reporting the 5-number summary, along with the mean and standard deviation, is an excellent way to convey information about both the central tendency and variability of the distribution. You have a growing collection of statistical tools that will help you understand the distribution of data that you collect in your research. These tools will also be useful for conveying information about distributions to others when you report your research results.